In this video, we're going to review how to name simple ionic compounds called binary ionic compounds. So when you have a metal and a nonmetal that form a compound, we call that an ionic compound. Um, so what we're focusing on right now are binary ionic compounds, which are simply two different elements, one metal, one nonmetal, making a compound. Binary meaning two. For example, NaCl, you have one metal, one nonmetal. There are some ionic compounds that have more than one element in it. For example, Na2CO3. This is still ionic because there's a metal in it, but there's more than two elements. So this would not be a binary ionic. This is a binary. This is an ionic compound with a polyatomic ion, as you might remember from grade 10. Our focus in this lesson is really going to be on these ionic compounds here, the binary ones. So these are the basic rules when you're naming binary ionic compounds. So suppose you want to name KBr. You name the metal first. The metal is always the element that's on the left. So the first element you see there. And then, so that the ending of the metal doesn't change, is simply potassium. There's nothing different there. Then you name the second element, but you have to change its ending to IDE from INE. The second element is the nonmetal. So bromine is the nonmetal. Change INE to IDE, becomes bromide. So really now you're just putting the two names together. So we have KBr is potassium, bromide. So here we have another example. So the metal is calcium, and the nonmetal is fluorine, but we change that to fluoride. So all binary ionic compounds, simple ones, when you're naming them, follow these rules here. Fairly straightforward. Metal first, nonmetal after, change the ending of the nonmetal to IDE. Just a few notes to remember. If you're changing the ending of oxygen, that becomes oxide. The nitrogen becomes nitride. They're similar but a bit different, right? Because the way we did it here, you just change IDE or INE to IDE. Here, there's no INE. It's oxygen. So it doesn't become oxygenide, it becomes oxide. Nitrogen does not become nitrogenide, it becomes nitride. Another one similar to that is sulfide. Sulfur becomes sulfide. Phosphorus becomes phosphide. And then hydrogen becomes hydride. So these are some of the more interesting ones that you should pay attention to. Don't forget that that's how you would change their endings. So you can practice doing these problems over here. So what you can do is pause the video and try it out yourself. For the columns where you have to name the metal ion and name the nonmetal ion, that's just for really if you need to show your work and you need to do it step by step. If you do it all in one step, that's fine. That's what I'll do when I write the answers out. So pause and try it yourself. So let's go ahead and try MgCl2. So that's magnesium, and then chlorine becomes chloride. And then CaS, well, we have calcium as the metal, and then sulfur is the nonmetal, and that becomes sulfide. Na2O, so we have sodium as the metal, oxygen becomes oxide. Li2O, lithium as the metal, oxygen becomes oxide. K2O, potassium as the metal, oxygen becomes oxide. We're going to skip HCl for now. Let's go to CaF2. So we already did that one in the previous slide. That was calcium fluoride. MgS, so we have magnesium. Sulfide. And then AlF3 is aluminum fluoride. And we're going to skip HCl for now because, as you can see, it's two nonmetals. This is a bit of a different one. You would just call it hydrogen chloride, but there's different naming rules for these altogether, so we'll skip that for now. So essentially, when you see metal and non-metal, you're dealing with an element, you're dealing with a binary ionic compound. You name the metal first, then the non-metal, change the ending to IDE. So sometimes you'll be given a name and you have to write a formula. So the formula will have the symbols of the elements that are involved and also subscripts, these small numbers here, which tell you how many of each element there is in there. For an ionic compound, this is really the ratio. Because if you remember from the previous review video that we saw, ionic compounds don't exist as individual units. There's no such thing as an NaCl molecule. Instead, it exists in this ratio of Na to Cl crystal. So what we do is we tell you for every one Na, there's one Cl in that crystal. So over here, for example, we'd be saying that for every 2 aluminums, there's 3 oxygens in that crystal. So your metals on the left, your non-metals on the right. And again, if you have a name, you can go from the name to the formula by following a few simple rules, and I'll show you that on the next few slides. So if you have magnesium chloride, and you want to find the formula, I'm going to show you 2 methods. I'm going to show you something called the crisscross method and something called the charge balancing method. We'll start with the crisscross method first because it's pretty straightforward. First, what you're going to do is you're going to write the ions side by side. So we have magnesium, and then you need to know the charge of magnesium. So let's go and take a look at our periodic table. Magnesium is in group 2, so +2, and chlorine is in group 17. 7 valence electrons, gains 1 electron, -1. So we have Mg2+, Cl1-, and what we do is we crisscross. We take this, bring this down here, take this, bring this down here, and we get Mg1Cl2. Notice the charges are gone as well, because in the final formula, you do not have charges. We know they're ions. We just don't put the charges in there. And to clean this up, I rewrite it like this, MgCl2. Because if there's a 1 there, you don't have to write it in. So basically just grab the charges from the top, crisscross them, and then afterwards get rid of the plus and the minus sign, and there's your formula. There's another method called the charge balancing method. I'll show you how that works. Ionic compounds, they have to have an overall charge of 0. Overall charge of 0. So this is more visual. If you appreciate the visual aspects of it, you're going to have Mg2+ and Cl1-. If you left this like this, 2+ and 1-, that's 1+. That's not 0 yet. So how do you make this overall charge of the Mg2+ and Cl- 0? Well, add another Cl1-, because this is now 2-, 2- and 2+, that's 0. So how is this a formula? Well, you literally write down a formula based on how many things you've drawn here. So we have 1 magnesium ion still. No need to put a 1, just Mg. And then our Cl, we drew 2 of them. So MgCl2. So you can choose to do the crisscross method or the charge balancing method, whichever one you're more comfortable with. Charge balancing, less room for error. We'll see why in a minute. So I've showed you the charge balancing method already on the previous slide. So let's try doing the formula for aluminum nitride. So I'll do the crisscross method first. So aluminum is +3. Nitride is 3-. Notice I know this is an ionic compound because there's a metal and then an IDE, which means that I was nitrogen turned into nitride. So what we do here is we have to crisscross. Al3, N3. And I drop the charges. Now here there's an extra step. Remember that I said that the formula for ionic compounds are ratios. They have to be the simplest ratio. So for example, if you have 2 over 4, the simplest ratio is 1 over 2. I divided everything by 2 there to get 1 over 2. So it's the same thing here. You need the simplest ratio. So my last step is to divide everything by 3. So I get the simplest whole number ratio, which is AlN. Aluminum nitride. Metal on the left, non-metal on the right. So make sure that if you have a case where you need to get the simplest ratio, you do that. That's called reducing. You reduce. If you were doing the charge balancing method, you'd have Al 3 plus, N 3 minus. 3 plus and 3 minus already equals 0. All you have to do is draw one Al and one N. That's Al N. So the benefit of the charge balancing method is that you don't really have to do the crisscross and the reducing because it's done for you by you just drawing in the ions to balance it out. So again, charge balancing method was done for you on the previous slide. Let's try this example over here, barium iodide. This requires your knowledge of knowing of making ions from the periodic table, knowing the valence electrons and so on. So barium is 2 plus, iodide is 1 minus. We can crisscross. So that's step 1, charges side by side, crisscross. We have Ba1, I2. We don't need to write the 1, so we can simply put Ba, I2. If you were doing charge balancing method, you'd have Ba2 plus, I1 minus. Right now, this is not equal to 0. This is plus 1. So we need to get rid of another plus 1. So we'll put 1 minus there. Now this is 2 minus. This is 2 plus. Overall, that's 0. So we have 1 barium, and we drew 2 iodines, or iodides, I should say, because it's the ion. Charge balancing method, already done on the previous slide. So you can pause the video and try these out. I'm going to quickly write the answers out so that you can check your work to make sure you understand all this. So let's start off with doing the formulas. So potassium bromide is KBr. Hydrogen sulfide. Now, here we have 2 nonmetals. I know I skipped it last time. Hydrogen acts like a metal in some cases, so you can treat it like a metal when you have a name like this, like hydrogen chloride, hydrogen sulfide, so on and so forth. So we'll treat it like a metal. It's in group 1, so it would have H plus, sulfur's 2 minus, crisscross it, you get H2S. So hydrogen's a bit weird. It can act like a metal. We'll go over that in more detail later on. Sodium phosphide, Na3P, barium oxide, BaO, barium iodide, we already did an example like that, magnesium iodide, MgI2. So again, you would have tried this yourself. Potassium oxide, K2O, calcium nitride. So let's just walk you through the steps of that. So Ca2 plus, N3 minus, crisscross, and we get Ca3, N2. Sodium fluoride, NaF, calcium oxide. So again, you have 2 plus, O2 minus. If you do charge balancing, you can see they're already balanced, so you just need 1 and 1. But here I'm just going to do the crisscross to show you you'd have to reduce, divide by 2, divide by 2, and our final answer is CaO. Silver sulfide, so silver is plus 1, sulfur is 2 minus, so 2Ag2S. Aluminum bromide, AlBr3, and then silver iodide, both a charge of 1, so AgI. So remember, your crisscross or your charge balancing when writing the formulas, metal on the left, non-metal on the right. Hydrogen, if you see it in a case like this, when it's not named as an acid, so hydrochloric acid, sulfuric acid, so on and so forth, you can treat it like a metal, give it a charge of plus 1, and then the other one follows the same pattern that you'd normally follow.